Captain's log, stardate 8755.7. Our ship's warp drive electronics have been damaged by a subspace plasma pulse. We have managed to achieve a weak orbit around Apicius 3, a Class M Earth-like planet in the Taotian system. We must try to repair our damaged systems. But this is a strange planet. It has no life forms, but appears to be littered with electronics identical to those from our planet Earth in the mid-1990s. First Officer Sprocket and Engineering Officer Shoddy have beamed to the planet's surface to try to identify the electronic components we need to save our ship. Time is critical.
Shoddy to Energizer! Come in!
Captain Quirk here. Shoddy, our computers indicate that our orbit will only last another 3 hours, 35 minutes. You have that long to find the electronic components you need to get the warp drive working, or the Energizer will crash.
I don't know, Captain. There certainly are a lot of electronics around here, but it's not gonna be easy matching 1990s components to our warp drive system.
I'm counting on you, Mr. Shoddy. Quirk out.
Well, I'd rather be fishing, but it doesn't look like the fishing's very good around this place. I hope that overgrown calculator of yours can do what you say it can.
This overgrown calculator, as you call it, is the new GC3, Galactic Component Comparison Computer. It contains data on electronic components from more than 2 million civilizations, spanning the last 1,000 years. It will enable us to match the components we need with those found on Earth in the mid-1990s. Here, take a look at an overview of electronic components from that period.
Electronic components are used to change electrical current flow in different ways. They come in many different shapes and sizes, and are used for a great variety of purposes. When mounting electronic components onto printed wiring boards, or PWBs, there are two primary types of components: through-hole components, which have leads that are fed through holes in the PWB and then soldered, and surface mount components, which are soldered directly to the surface of the PWB onto thin metal areas called lands or pads. There are a great many styles of through-hole components. Components with a lead protruding from each end of the component body are called axial lead components. Typical axial lead components include resistors, diodes, and capacitors. Components with 2 or more leads protruding from the component in the same direction are called non-axial or radial lead components. Typical radial lead components include various kinds of transistors, capacitors, diodes, filters, and crystals. Surface mount devices, or SMDs, have become an increasingly popular alternative to through-hole components. Instead of inserting a leaded component through a hole in the circuit board, SMDs are placed onto pads or lands on the surface of the board and soldered into place. Many through-hole components have surface mount equivalents, which are much smaller in size. SMDs don't have long wire leads because they don't attach to holes through the board. Instead, they attach to PWBs in one of two kinds of ways. The first way is with special leads, which allow them to be soldered to a land on the surface of the board. One surface mount lead style is the J lead, where the leads are formed to resemble the letter J. The bottom of the J is soldered to the board's land. Another surface mount lead style is the gull wing, where the leads extend from the body of the component in a shape that resembles a gull's wing. The other way surface mount components are attached to PWBs is by some form of metallized termination. A metallized termination means that the surface of one or more ends of the component is covered with metal which is soldered directly to the land. These components are also sometimes referred to as leadless because they don't have metal leads sticking out from the body of the component. Leadless components include chip components and the leadless chip carrier, called the LCC for short. The most common type of metallized termination component are chip components, with their 3- or 5-sided terminations at opposite ends of the component's body. But whether a component is through-hole or surface mount, each has a specific function. Many components must be placed onto or into the printed wiring board in a certain way. When a component must be installed a specific way, it is called orientation. When the component has a positive and negative connection that must be made in a certain way, it is called polarity. Understanding the polarity and orientation of components is an extremely important part of component identification. If a component is installed on the board incorrectly, it could damage the component, the printed board, or other components in the assembly.
If I wanted a history lesson, Mr. Sprocket, I would have asked for one. The time's slipping away. Where do you suppose we might be finding some of the components that we be needing?
My sensors indicate there is a concentration of electronic components just over that rise. So what is the first component we need to fix the warp drive system?
Well, I need a phase inducer for the warp drive's magnetic containment field. See what your galactic thingamajig has to say about that.
It says we need a 33 microfarad 6-volt DC polarized capacitor.
You don't say. And just what might a 33 microfarad 6-volt DC polarized capacitor look like?
Take a look.
Capacitors are the most widely used component in electronics of this era. They have the largest variety of shapes, sizes, and identifiers of any electrical component. Capacitors store and change the flow of electricity in a circuit and can be polarized or non-polarized. Through-hole, non-polarized capacitors usually have 2 leads and can be loaded in either direction. They are usually small and have a low electrical value. The different types include ceramic disc capacitors, dipped mica, dipped ceramic, mylar with round or oval bodies, and various sizes of box film capacitors. Polarized capacitors, whether axial or radial, will have either the positive or negative lead marked. The positive lead can be marked or formed in several ways, with a symbol like a plus, dot, or band. The positive end can also be marked by a colored end or a silver square, or by a ridge or bubble. If both ends have a bubble, the larger bubble is the positive end. A stripe with arrows down one side of the capacitor will point to the negative lead, while a band with minus symbols marks the negative lead on this electrolytic capacitor. Sometimes the positive end is marked by a longer lead. Surface mount capacitors are often chip style. They have metallized terminations on each end of a ceramic body, usually wrapping around the end on all 5 sides. Polarized surface mount capacitors will have the direction of polarity or installation marked by a line or letter A, or by a beveled edge on the positive end. Writing on both through-hole and surface mount capacitors will indicate the value in picofarads, nanofarads, or microfarads. Writing on the body of the capacitor also includes the voltage, the tolerance, and sometimes the temperature range, a part number, or the manufacturer. Some through-hole capacitors will have colored bands indicating values and multipliers. This is the capacitor you're looking for, a 33 microfarad, 6-volt DC polarized capacitor.
Well, now that we know what it is, all we have to do is find one.
I believe this is your first chance.
My, what a beautiful antique.
It should contain a capacitor.
Well, let's just take a look. What does your computer say about this little fella?
I believe, since this has leads protruding along the axis of the component body, this would be an axial leaded component. However, the GC3 indicates this is a resistor, not a capacitor.
Resistors limit the electrical current in a circuit. They are made of a variety of materials, including carbon composition, metal or carbon film, or metal oxide. Through-hole resistors are usually cylinders with 2 axial leads for through-hole mounting, while surface mount resistors are either chip-style or cylinders. Fixed resistors don't have polarity. The size of a resistor grows as its wattage rating increases. Wattage is the amount of electricity the resistor can handle. The value of a resistor is expressed in a unit of electrical resistance called ohms. Axial resistors will usually have 4 or 5 colored bands, which are read using a color chart telling you what the value of that resistor is. The color band system is called the universal color code. Surface mount chip resistors and some through-hole resistors are number-coded instead of color-coded, with the ohm value and tolerance.
Universal color code? Their concept of the universe was a bit limited back then, wasn't it?
Aye, Mr. Sprocket, indeed it was. Now this one doesn't have many stripes, but it's small and it looks about right.
No, that appears to be a diode.
Diodes allow current to flow more easily in one direction than another in an electrical circuit. All diodes are polarized and have an anode, or positive end, and a cathode, or negative end. Through-hole diodes are usually axial, and the negative lead is marked with a band, arrow, or diode symbol for correct placement on the board. One type of through-hole diode, which is usually radial leaded, is the light-emitting diode, or LED. LEDs radiate light and also have an anode and cathode side. The cathode, or negative side, can be identified by a flat edge, notch or tab, a dot or shorter lead. Surface mount LEDs are less common and usually have metal terminations. Surface mount diodes are sometimes gull-wing, meaning the component's leads are shaped roughly like a gull's wings. The direction of installation is marked by the lead configuration. But surface mount diodes are often packaged in a tubular shape with metallized terminations at each end. The direction of installation is marked by a band or stripe. These leadless cylindrical diodes are called metal electrode face, or MELF for short.
Great Scott, it sounds like a bloody alien. I'll take another look. This had better be it.
That, Mr. Shoddy, is a 33 microfarad 6-volt DC polarized capacitor.
Thank goodness. I was running out of options in there.
What do we need next?
It's simple, laddie. The warp plasma inducer in the dilithium chamber blew its infuser array all to pieces.
The GC3 says we need a TO220 transistor. Here's what it looks like.
Transistors are used for a large variety of purposes in electronic circuits and come in a wide range of through-hole and surface mount styles and sizes. Through-hole transistors usually have 3 or 4 radial leads. They are identified by their names, such as TO92, TO18, TO251, or TO220. The numbers are standardized in the industry and refer to the physical size of the transistor package. Installation direction is usually marked by a tab or flat sides on the body of the component. Surface mount transistors come in packages called small outline transistors, or SOTs, with names like SOT23 or SOT223. These transistors have between 3 and 5 gullwing leads. Installation direction is determined by lead configuration. Another kind of surface mount transistor is the D-pack, which are surface mount versions of larger through-hole transistors, like the TO92 or the TO220. D-packs have 3 gullwing leads. The TO220 you're looking for is a 3-lead through-hole transistor.
The sensors indicate there is not one available inside this electronic device. However, there is one 952.7 kilometers from this location.
Shoddy to Energizer.
Quirk here.
Captain, please beam us to the location identified on Mr. Sprocket's GC gizmo.
Affirmative. Beaming now. Quirk out.
I wonder if there's fish in this river.
Of greater urgency, Mr. Shoddy, is locating the transistor we need.
It's probably inside that.
I believe you are correct.
Let's see what we have here. Now, this looks like a transistor.
According to the GC3, that is a crystal.
Crystals, which are also sometimes called oscillators, produce consistent electrical pulses or vibrations. A crystal's value is measured in megahertz and is printed on the component. Some crystals have polarity, some do not. If they do have polarity, the direction of installation is indicated by an angled or sharp edge or a dot. On surface mount crystals, installation is marked by a beveled corner.
You will remember, Mr. Shoddy, that the component we are looking for has 3 leads.
Aye, Mr. Sprocket. I do indeed. Well, let's just take another look. Okay, if it's 3 leads you want, here, 3 leads.
That, Mr. Shoddy, is a filter. An EMI PC filter, to be exact.
There are several types of filters, including EMI PC filters. Most filters are made of a ferrite material and are designed to filter electrical noise in a circuit. Surface mount filters are often chip style, although they can also be a cylindrical MeLF.
Here's another with 3 leads.
No, that's a potentiometer.
Potentiometers are variable resistors, whose value can be changed by an external control, such as a rotating shaft or a screw. Larger potentiometers with rotational shafts are used where constant adjustment is needed, such as the volume control on a television set. Smaller potentiometers, also called trim pots, have a small control screw. Surface mount potentiometers are much smaller and have the adjustment screw on the top or side of the component where it can be easily reached. That is a miniature through-hole potentiometer, or trim pot.
Well, how in blue blazes am I supposed to tell the difference between these things? Why doesn't the circuit board tell me the names of the components?
Actually, Mr. Shoddy, it does. Printed on the board are tiny letters. A code, if you will.
The letters which identify where each component should be placed on a board during its manufacture are called Component Reference Designators, or CRDs. They are a kind of shorthand or code which tells what component goes where on the board. CRDs are silkscreened by the board's manufacturer onto the printed wiring board in non-conductive ink. The markings sometimes include a body outline of the component, or the polarity or the direction of installation. All these marks work together to tell the operator building the printed board assembly which component to install and the direction the component should be placed on the board.
Well, this is more like it. What's the letter for a transistor, then?
According to the GC3, Q.
There's a Q.
That's a CAN-type transistor, a TO39. That other one, that's the TO220.
Very well, Mr. Sprocket. Finally gotcha.
So what's the next component you need?
Well, we need a field induction sub-processor for the plasma conduits. I don't see how we're going to replace that.
You need an integrated circuit, or an IC. But the GC3 indicates there are several types which may work.
Where does it say the nearest one is, Mr. Sprocket?
According to the GC3, the nearest satisfactory IC is 480.3 kilometers from here.
Shoddy to Energizer.
Quirk here. How are you doing, Mr. Shoddy? Our orbit is rapidly decaying. Have you found what we need?
We have only one component left to go, Captain. Beam us to the location indicated by Mr. Sprocket's GC3 contraption.
Affirmative. Hurry, Shoddy. Beaming now. Quirk out.
I wonder if there's fish in that lake.
Mr. Shoddy, I assume the captain was earnest in his appraisal of the ship's deteriorating orbit around this planet. I suggest we find our component and return to the ship as quickly as possible.
Aye, Mr. Sprocket. So just what kind of constipated circuit are we looking for?
I believe it is called an integrated circuit.
Integrated circuits are like packages of components which have been assembled or integrated together on a single piece of silicon. ICs might have groups of transistors, diodes, resistors, or capacitors, and range from very simple, like this resistor network, to the very complex, like this state-of-the-art microprocessor, which combines over 4 million components on a piece of silicon no larger than your fingernail. ICs come in a variety of packages for both through-hole and surface mount applications. The most common type of through-hole IC is the dual inline package, or the DIP. A DIP has 2 rows of leads parallel to one another, which project from the body of the IC. Each of the DIP's leads may be soldered onto the board. It can also be inserted into a socket whose own leads have already been soldered to the board. This makes removing and replacing the actual IC a solderless operation. Similar to the dual inline package is the single inline package, or SIP. This component has a single row of leads, like this SIP resistor pack or diode array. More complex through-hole ICs are packaged in pin grid arrays, or PGAs. The 2 most common types are the ceramic PGA and the plastic PGA. Surface mount integrated circuits often look similar to their through-hole cousins, but are much smaller in size. Surface mount ICs also have leads designed to sit on the printed wiring board rather than being inserted through the board. The most common surface mount leads for ICs are the gull wing and the J lead. The surface mount cousin of the through-hole dual inline package IC is the small outline integrated circuit, or SOIC. The SOIC has 2 rows of gull wing leads instead of through-hole leads. The SOJ, or small outline J-lead package, simply has J-leads instead of gull wing leads. Larger, more complex surface mount ICs, like microprocessors, may be packaged in one of a variety of components with leads on 4 sides, such as a PLCC, which stands for Plastic Leaded Chip Carrier, QFP, or Quad Flat Pack, and BGA, or Ball Grid Array, the cousin of the Pin Grid Array. Another type of surface mount IC package is the Leadless Chip Carrier, or LCC. This package uses half-round metallized recesses, called castellations, around the edge of the component body. The solder fills these recesses and connects to the surface pad on the board. All ICs have polarity, so placing them on the board correctly is very important. It's not a negative or positive lead you'll be looking for with an IC. Instead, a dot or notch will mark the number 1 lead. A matching mark on the board will show how to align the IC.
That's a lot of components, Mr. Sprocket. Just what in the devil do we need?
We are looking for an SO28, an SOJ28, or a DIP28 resistor network.
And the differences in the leads?
Correct. The SO28 is a 28-lead, small outline gull-wing lead IC. The SOJ28 is a J-lead version of the same component, while the DIP28 is a dual inline package with through-hole leads. Any one of them will replace the warp drive's field induction subprocessor.
And just where are we looking for this SOJ DIP?
This area appears to contain a number of electronic components. The component we want is on this board here.
There's an SIP. And there's an SO20. And there's a QFP. Aha, there's a DIP with 28 leads. I'm getting pretty good at this, Mr. Sprocket.
Indeed you are, Mr. Shoddy.
The DIP28 appears to be in some kind of holder.
Fascinating. That is a socket. Sockets are soldered on the board just like components. This allows the IC to be inserted and removed without soldering and desoldering. Try gently removing the IC.
There we are.
Sprocket to Captain Quirk. 2 to beam up.
Captain's Log. Supplemental. First Officer Sprocket and Chief Engineer Shoddy returned safely with the electronic components needed to repair the warp drive electronics. Mr. Shoddy successfully installed the components, and we are preparing to leave our orbit around Apicius 3. But first, Mr. Shoddy has returned to the planet's surface to engage in some additional research on late 20th century Earth electronic components.